It's the biggest self-propelled machine in the world, the F-60 conveyor bridge. The steel giant is located in the Reichenwalde open cast mine in the Lausitz region of eastern Germany. Two bucket chain excavators dig overburden that the bridge conveys to the other end of the pit. Since the 1970s, the F-60 has been moving up to 90,000 tons of material per shift.
It's exactly 500 meters from one end of the bridge to the other.
Some 5,000 men and women work in the Lausitz lignite mines, day in and day out. 4 conveyor bridges are in operation in the Lausitz coalfields today. To avoid downtime, major repairs are planned years in advance. Repairs can take months, and everything's carefully planned to avoid delays. About 10% of the kilowatt hours consumed in Germany comes from power plants powered with Lausitz lignite. And these plants depend on the F-60 conveyor bridges.
This is the brain of the plant, where everything's monitored and controlled.
Most of the lignite mined here, also known as brown coal, is used to generate electricity in German power plants. If an F-60 isn't operational, the country's electricity supply is at risk.
This is what it's all about, black gold.
Every shift, 14 men and women head to the mine to operate the enormous machine. It's hard work. At the Reichenwalde open cast mine, a crew car is bringing the team to their shift. They're all coal miners, some like their parents before them. The lignite mines and the affiliated power plants have long been the region's largest employer. The previous crew can't leave until the next one arrives. The shift change has a set routine, and there's an unwritten law that it can't be delayed. The conveyor bridge has a crew of 14. The control room is Command Central. This is where the head operator controls and monitors the entire operation. From the speed of the conveyor bridge to when it stops to the digging. The entire process is monitored by video camera.
The monitors help us keep an eye on the things that are too far away to see and we don't have access to, but they still have to be monitored.
The F-60 is divided into 2 sides. The workhorse of the machine is the excavator side, where the digging takes place. The conveyor bridge can remove 60 meters of soil at a time. That's also where its name comes from, the F-60. The other side is the dumping side, where the overburden is deposited. The overburden dug up from the F-60's excavator side is transported by conveyor belt to the dumping side. The massive dirt and rock is dumped in 4 different predefined spots. That way, the layer of excavated dirt is gradually replaced over the spent coal seam to reclaim the pit dug up more than 500 meters away. The conveyor bridge, which was designed in Lauchhammer, was completed in 1974. The F-60 wasn't the first conveyor bridge ever built, but it was the biggest. And it was the pride and joy of East Germany's lignite industry, helping to fuel the mining boom. The conveyor bridge remained in operation through a turbulent history, surviving the fall of communist East Germany and German reunification. And despite the rise of green energy and the nuclear power exit, the F-60 continues to chew its way through the terrain around the clock, day after day. During its first year of operation, the icy winter almost spelled its doom. The East German Army had to move in to keep the bridge free of snow and ice. Had the machine come to a standstill, moving parts could have frozen and suffered serious damage.
We're working here so that the coal will keep flowing to the Boxberg power plant. As long as this coal snap continues, we'll have to keep at it here.
The machine remains in operation around the clock, only stopping for 10 hours once every 7 days. That's when maintenance work is done. and any worn-out parts are replaced. The conveyor belt rollers are most liable to wear and tear.
The conveyor belt consists of small islands, or sections. Each island is made up of 5 rollers in all. Those rollers are what move the entire belt. Depending on how much material is on the belt, the rollers will have contact with it or not. Sometimes the roller's bearing will wear out. Then we have to stop the conveyor belt, remove the roller, install a new one, and start it all up again.
A bird's eye view gives a true sense of the F-60's vast size. It's 502 meters long, 74 meters high, and 204 meters wide. 5 soccer fields would fit under the bridge. Since the late 1970s, lignite mining operations have been traversing the region. At first, lignite was mined near Mühlrose in Saxony. In the 80s, the industry shifted toward Nochten. In the 1990s, it looped left. Then around 2000, it made an about turn. Now, the open cast mines are making their way toward Mühlrose again. The F-60 conveyor bridge doesn't dig up the lignite, it just exposes it. The overburden is tipped out on one end, just a few minutes after it's dug up on the other side of the pit. There's no need for interim storage. One excavator operates in the low cut, the other on the high cut. The 2 cutting edges are 60 meters apart. A bucket wheel excavator removes the upper soil layer, which is about 10 meters deep. A thin layer of lignite, called the top seam, lies beneath that. That's dug up by the coal excavator. The next stage is where the F-60 comes in. Sand, rocks, and soil have to be removed first. A bucket chain excavator removes the first meter. This valuable topsoil is transported by the conveyor belt to the other side of the pit. That's where the topsoil is dumped out again. It serves as the basis for reclaiming the pit. The soil travels more than 20 kilometers on the conveyor belts, one loop around the entire strip mine.
The amount of overburden we transport per shift always depends on what it is. Whether it's clay soil, or sandy soil, or full of gravel, we can move an average of 40 to 50,000 cubic meters per shift.
The ground in the Lausitz mining region has a typical structure. The top 10 meters or so is the pre-cut. Then comes the top seam, which is a 3 to 5 meter thick layer of lignite. After another 60 to 100 meters comes the main seam, which can be up to 15 meters deep. The pre-cut excavator has several conveyor belts, which remove the overburden. That 200-meter-long excavator is a multitasker. In the front, it can excavate a large area. In the back, it deposits this overburden on the conveyor belt with precision. These excavators are among the largest land vehicles in the world.
What's special here in Nochten is the top seam. We excavate that and move it to the coal handling system. That's followed by the conveyor bridge, which operates on a kind of one-to-one basis. It also uses conveyor belts, but they travel a shorter distance than what you see here at the pre-cut. The conveyor bridge dumps out what was dug up on one end directly at the other end. Whereas right now, we're still taking the long way round.
Next, the lignite is excavated from the Nochten open cast pit. That's done with a bucket wheel excavator. Each bucket can remove up to 710 liters of material. That's how the lignite is dug up. This bucket wheel excavator is essential to modern lignite mining. The machine can excavate as much lignite as 40,000 miners used to shovel up during a single day. The huge excavator is run by the operator, who has to make sure it digs up only lignite, with a minimum of soil. His perch moves back and forth constantly, mirroring the motion of the excavator.
The previous shift excavated 11,075 tons. We've done 4,800 so far. Under good conditions, you can move 14 to 15,000 tons with this machine.
Bucket wheel excavators are among the largest mining machines. The biggest ones are about 200 meters long and nearly 100 meters tall. At 13,500 tons, they're the heaviest land vehicles in the world. The excavator consists of an undercarriage, a rotatable superstructure, and a conveyor system. Moving on its crawler tracks, it digs up the lignite, removing it from the ground one scoop at a time. The boom can slew and swivel, providing a large range of motion. Up to 15,000 tons of lignite can be moved per shift. The excavator deposits the lignite directly on a conveyor belt. From there, it's transported directly to the power plant, 10 kilometers away. Less than 30 minutes after its arrival at the power plant, it's already being burned.
The rotating motion fills the buckets with lignite, which then moves along the excavator's conveyor belt. It has a bucket wheel conveyor and a loading conveyor. The lignite is discharged onto that big conveyor belt unit, and then it's transported to the power plant.
This is what the lignite looks like. Nearly 18 million tons of it are mined here in Reichenwalde every year. For each ton of lignite, 6 tons of overcast are excavated. That works out to about 100 million tons of material per year.
This is typical Lausitz lignite from the second seam. It's 17 million years old. This is what it's about, black gold. That's why we have this huge operation. 95% of the lignite we mine here is turned into electricity in our power plants.
The lignite is moist due to groundwater. It's about 56% water to start, so it wouldn't burn. Before the lignite is turned into briquettes, the water has to be removed. In the power plant, the lignite is then ground into dust and burned. A conveyor belt system extends from the bucket wheel excavator to the Boxberg power plant. 15 kilometers away, the system traverses the entire mine from one conveyor belt to the next. The lignite is either loaded onto railway cars for transport, or it's put into temporary storage. Each crocodile, as these green locomotives are called here in Lausitz, can pull between 25 and 30 railway cars. There's always a supply of lignite in storage at a power plant. If a train is delayed or if the conveyor unit stops working, the plant can still generate electricity using the lignite stored nearby. 2 power plants are located near the mine, the Schwarze Pumpe facility and the Boxberg facility. This is where lignite is transformed into electricity. The lignite is burned and the resulting energy is used to generate steam. The steam powers turbines that convert their motion into electricity. The Schwarze Pumpe plant has 2 blocks, Block A and Block B. Each one has 8 mills that grind the lignite into dust. That's used to fire the boilers. Temperatures here reach 1,000 degrees Celsius. Both blocks are controlled from this command center.
In the command center, the operator controls an entire block, from the lignite grinding to the burning, the steam generation and the electricity generation at the turbine. He monitors all the parameters, in essence controlling the power plant.
The fire generated by the lignite dust turns water into steam. That steam is under high pressure, which then turns the turbine's paddle wheels. Generators are located at the end of the turbine shafts, which operate much like a dynamo on a bicycle. The kinetic energy is converted into electrical energy. The steam is then cooled by condensers using coolant water fed into two large cooling towers. The elevators in the power plant don't go to specific floors. They go to specific heights in meters. In the event of an emergency, this ensures that it's always clear exactly where the problem lies.
When both blocks are operating at full capacity, we generate 1,600 megawatts, enough for 3 million households.
The power plant could power nearly all of Berlin. But lignite-fueled power plants in Germany don't always operate at full capacity. When electricity from renewable sources, such as wind or solar energy, is available, the plant reduces its output and uses less lignite as a result. This adjustment can take place at intervals of 15 minutes or less, if need be. A new shift is about to start at the F60 overburden conveyor bridge. Bridge manager Matthias Geldrich is on his way to the mine. All senior managers are assigned an all-terrain vehicle. The ground is far too soft to drive to the conveyor bridge. That's also why the F60 runs on rails. The conveyor bridge uses 6 tracks on the excavator side. On the digger side, there are another 3.
The tracks are key. On the excavator side, the bridge is moved by 256 wheels, which distribute its weight. If it had lots of small separate wheels or groups of wheels, it would probably sink into the ground.
That's also due to its immense weight, 13,500 tons for just the bridge, even without the excavator. By contrast, a jumbo jet weighs just 300 tons. What's more, the excavator and the dumping side of the F60 can move in 2 different directions.
The excavator side can move independently, but the bridge has to move as a unit, or it would split apart. Both the excavator and digger sides travel at a rate of 400 meters an hour, in unison.
The entire conveyor bridge, including the 2 excavators, is powered by electricity. It's supplied to the bridge via a cable at 30,000 volts. The cable operates much like the cable of a vacuum cleaner, on a much larger scale. A total of 6,000 meters of cable are wound on this drum. The cable is wound or unwound onto or off the drum, depending on which direction the bridge is traveling. That gives the F60 an operating range of 6 kilometers. The F60 is powered by 2 electric motors, which supply more than 1,800 horsepower. The motors connect directly to the powertrain, without the use of gears. The amount of power needed from the motors depends on how deeply the excavator boom is driven into the ground. If the electric motor is overloaded, it switches off automatically. The bucket chain excavator operates on the high cut, excavating material at a steady pace. As the heavy buckets are pulled across the ground, they fill automatically. At the end of the boom, the bucket is emptied and then returns on the top side of the boom, back up the embankment.
This is where the entire mining operation begins. That's where the material is excavated from the high cut. It's moved along the conveyor belt and ends up in a central collection point between the two transverse conveyors. Then it's transported along the conveyor bridge.
When the excavator is working on the high cut, the operator has to monitor the angle of the boom. Due to the weight of the material being excavated and the excavator's movement, the cabin is in constant motion.
Right now, it's at the gentle setting, so we're not moving much. Now I've sped it up, so we're shaking a bit more.
Both excavators can remove up to 45,000 tons of soil per shift and send it across the F-60's conveyor belt to the other side of the pit. But they can't remove too much. The boundaries of the pit are clearly defined.
There are stakes over there, and we have to maintain the proper angle with the excavator boom. Right now it's at 31 degrees, so that's what we have to maintain.
The second excavator then exposes the lignite in what's called the low cut. The operator must not damage the seam or dig up any of it. What's excavated here is tipped out right away on the other side, so any lignite dug up would be lost.
Our job is to expose the seam of brown coal. We have to try to leave the lignite itself untouched. There's sometimes a layer of sediment on top of it. It's light gray. That has to be removed too, of course.
Large rocks, also called erratics, can pose a problem. They can weigh up to several tons. When the excavator operator uncovers a rock like this, he has to push a warning button on the console. That's why the operator needs to keep a sharp eye on the bucket chain at all times. If a large rock ends up in one of the buckets, he has only about 15 seconds to react. Then he pushes the button to activate the rock grate, which is hydraulically lifted into the stream of overburden. The rock is removed so that it doesn't end up on the conveyor belt.
Any rock that's more than, say, 50 centimeters long would do a lot of damage to the conveyor unit. The roller areas are the most likely to be damaged.
The hydraulic rock grate is like an insurance policy for the enormous machine. A large rock could do serious damage to the conveyor bridge. But it's not just rocks that pose a problem. The grate is also used to remove large, hard clumps of clay. In areas where the soil has a high clay content, the excavator has to operate more slowly. Once the overburden reaches the other end of the pit, it's disgorged in one of 3 different spots. A 3D scanner monitors the height of the overburden layers, continually monitoring the process.
The scanner allows us to monitor the overburden that's being poured out here and how high it is. It should all end up at exactly the planned height.
The overburden that is being dumped here will reclaim the pit. Every layer is carefully planned. The soil composition determines which conveyor belt the overburden is poured from. That way, various types of soil will be deposited in predefined layers.
The first layer that's poured helps support the layers that come after it. The first one supports the second one, and so on. Some of the overburden is quite wet. Pouring it in specific layers helps keep it in place, so that it won't slide.
The conveyor bridge is constantly creeping forward toward the high cut, moving its way slowly but surely through the landscape. A few weeks from now, the F-60 will have reached the spot where the lignite is currently being excavated. It's a big loop. On one end, a pit is excavated in the ground. At the other end, it's filled up again. The crew makes sure that the soil composition on the reclaimed side ends up exactly as planned.
They're digging over there and dumping behind me. The overburden that's dumped helps keep the bridge on stable ground. We can't just dump it all randomly, or the tracks and bridge might subside into the ground.
To make sure the bridge is standing on solid ground, rainwater has to be pumped out around the clock. There's a special crew assigned to the task. Along with rainwater, groundwater often starts seeping into the pit. That water is collected in small sinks, from where it's also pumped out. Water from aquifers can also start to seep through the soil. If a heavy rain comes on top of that, the F-60 could be washed out. The crew makes sure that doesn't happen.
We collect the water that pours in along the entire embankment, including behind us here, and we pump it out.
The tracks that keep the entire operation moving forward also have to constantly creep forward. That's where the special track building machines come in. They constantly shift the tracks forward toward the pit that's under excavation. Like an ordinary locomotive, these machines are diesel-electric. At 31 meters long, they weigh about 100 tons and sport a 6-cylinder, 280 horsepower diesel engine. To move the tracks have to be grabbed by the pulley seat. First, the tracks are raised by the lifting roll. Then, the pressing roller pushes them in the desired direction. At first glance, it looks like the tracks are drifting.
The lifting roll lifts the tracks and the pressing roller guides them in the right direction so that they can be shifted. The track shifting machine will now lift the pulley seat. It moves the pulley seat in the desired direction by no more than 40 centimeters. Now the track shifter drives backwards and the tracks will be shifted bit by bit toward the high cut.
The track shifting machine always shifts 2 tracks at once. They're connected to each other. That speeds up the process. The operation can be carried out at a temperature range of plus 30 degrees Celsius in summer to minus 30 degrees in winter. But there's one temperature that poses a problem.
At about 4 degrees Celsius, things get a bit tricky. That's where the iron is more fragile and could break. Then we can only move shorter sections at a time to make sure it stays intact.
The track shifting machines are also equipped with a caterpillar drive. That allows them to travel even when they're off track. At the Reichenwalde open cast mine, work takes place on 2 levels. There are 3 track shifting machines in operation at the main level. At the work area on the dumping side, 2 such machines are in operation. Each track shifting machine has a driver and an assistant. The assistant sits on the other side of the machine and monitors the process. In the event that a track breaks, he raises the alarm and notifies the driver.
It looks like we're driving sideways. That's because we're shifting the track. The wagon in the rear is driving on top of the track we just shifted, so we're moving at an angle.
To orient themselves in the mine, the crews use a GPS system. The mine surveyors lay the groundwork. They measure and survey the area, conducting a cartographic analysis and mapping out every stage in the mining process. They also monitor how much lignite is mined. Using this GPS data, a new 3D coordinate map is created every day. Using that, the surveyors can determine exactly how much overburden has been excavated.
The excavator has a display showing me how much material I've shifted. The mine surveyors use aerial photos to monitor the embankments, calculate how much was removed, and compare that to the amount reported by the excavator.
The aerial photographs are taken by drones and from airplanes. So that the images can be processed, the surveyors have to lay out what are called control points. These black and white markers are put down at preset locations. That way, the separate aerial images can be aligned and joined together later.
We take multiple images and combine them into a larger one. These control points show us where to match them up. The points have specific coordinates, the X, Y, and Z coordinates. We click on those points in the software, and the separate images are then instantly joined together using those coordinates.
Mine surveyors have always been a part of mining operations going back centuries. They serve as neutral observers who determine exactly where the excavation should take place. They're essential for maintaining an overview in the enormous mining operation. The surveyor is commissioned by the local authority, and his word is law. He also carries out geological surveys and reports, compiles documentation, and assesses the area that's being mined.
I fly the drone over a set route. Then I'll look for the control points using the software and join the images together.
The surveyors calculate exactly how much lignite was excavated. In the past, this work had to be carried out on the ground. Now, aerial drone images make the work faster and easier. And the drones offer another advantage.
We use the drones to keep tabs on corrosion, monitoring the bridge one section at a time. In the past, we'd have had to put up scaffolding to do that kind of monitoring. We can also use the drone to monitor for other defects.
Fridays are when maintenance work is done, all according to schedule. The F-60 goes offline for 10 hours every week. All the parts that are subject to wear are inspected and replaced if need be. This bending roller turns one of the conveyor belts. It weighs almost 600 kilos. It's worn and needs to be replaced. That means calling out the heavy machinery.
You can see the bending roller shows signs of wear and tear, quite a bit on the surface. So it's scheduled for replacement. We'll install a new one, and then work can continue.
Other more mundane maintenance tasks are also carried out. For example, the mining operation kicks up so much dust that the bridge starts to groan under its weight. All of that dust and rubble has to be removed regularly. The crew also carry out small repairs on the conveyor belt system. It all has to be done within 10 hours. But sometimes the maintenance work takes more than a day. A major overhaul of the conveyor bridge was carried out in 2016. The large equalizer and the roller table had to be replaced. Preparation for the work began with a study that was carried out in 2008. In 2013, the entire operation was mapped out in a 3-year planning phase. The same company that built the F-60 in the 1970s was commissioned to carry out the work. In April 2015, work began on the new steel structure in the eastern German town of Plauen. Nearly a year later, in February 2016, the structure was complete. Quite a few parts had to be made to order. Back in 1974, when the F-60 was originally built, no one imagined that this kind of refurbishment would ever take place. At the Takraf company premises in Lauchhammer, the roller table was built and put together. Then it was dismantled again and readied for transport to the conveyor bridge. The roller table's main modules weigh more than 200 tons. Loaded on the heavy load transporter, the modules are driven to the pre-assembly location at the Nochten mine. The new large equalizer, which is comprised of 7 main modules, was delivered to the pre-assembly location in February 2016. The crew then affixed the components called sashes. The roller table is also assembled here. The precision fit of the various components has to be checked, even if the weather's not cooperating. The large equalizer is finally assembled and is ready for painting. First, a scaffolding is erected, and then the unit is treated with an anti-corrosion agent. The yellow base coat is then prepared. Later, that's followed by the green and gray intermediate and top coat. The assembly area is situated adjacent to the conveyor bridge tracks. The first concrete elements are poured, serving as measurement points for the surveyors. The foundation of the assembly supports, which will support the finished bridge on the excavator side, also have to be poured. A number of foundation platforms are being erected especially for the maintenance and refurbishment work. They'll be dismantled when it's done. These auxiliary structures consume a total of about 450 tons worth of material. The bridge is taken out of commission for 13 weeks, and 50,000 work hours go into the refurbishment process. The 2 green construction supports have been put together on the pre-assembly area. They will be transported to the conveyor bridge, where they will wait by the foundations. On July 21, 2016, the conveyor belts on the bridge make their last run. The biggest self-propelled machine in the world is shifted into repair mode. The assembly supports can now be pulled into an upright position. Hydraulic presses, which can carry a load of 1,400 tons each, lift the conveyor bridge 50 centimeters into the air. For the next weeks, they'll relieve the equalizer and roller table from duty. The lifting procedure gets underway. A shaft collar is installed to secure the device. 230 bar correspond to a load of some 460 tons. Then the roller table dismantling begins. The blue sliding device is positioned over the roller table. Using wire rope hoists, also called Luxemburgers, the roller table is pulled into position for removal. Once the old roller table is in position, special hoists are attached to it. The crane will use these hoists to lift the roller table and then lower it beneath the F60. After about 60 minutes, the roller table has been dismounted and is ready to be removed. That job will be done by a truck with a special trailer. The undercarriage is driven underneath the roller table, which then rests on it. The roller table sets out on a brief final journey. Just a few meters away, work crews begin to dismantle the old roller table and turn it into scrap. Meanwhile, the auxiliary structure that will help remove the bridge's cross conveyor has been assembled. 8 150-ton presses are being attached to the support legs. That takes the load off the large equalizer, the centerpiece of the F60. Every day, a crew of 92 work on the project. The maintenance work and replacement of worn components will take more than 3 months. Now, the hoists help bring the large equalizer into position. where it can be lifted with 2 crawler cranes. Another special vehicle now moves into position. A heavy load trailer with 20 axles. The large number of wheels allow the 315-ton trailer to distribute the weight of the large equalizer and carry the load. The trailer shifts into motion. At a speed of just 5 kilometers per hour, the old large equalizer is brought to the pre-assembly area. Now comes a special moment. The old and the new equalizer meet en route. 8 years of planning and 3 years of preparation went into making this moment happen. Early in the morning on September 6, 2016, the new equalizer is moved to the conveyor bridge and then moved under the bridge. Special hoists are attached so that the equalizer can be lifted. 2 heavy load cranes lift the large equalizer onto the sliding tracks. After the crane hoists are unbolted, the equalizer is then pulled into the assembly position using chain hoists. Bit by bit, the equalizer slowly moves into position. The new roller table is also making its way towards the conveyor bridge. It will also be lifted under the sliding tracks by heavy load cranes. Every step in the work process was carefully planned and scheduled years ago. The roller table is finally attached to the blue pull rods and then lifted. After the crane hoists are dismantled, the roller table is also pulled into the assembly position. The hydraulic presses on the construction supports now release the bridge. The construction supports are now dismantled and removed. The supports are driven to the pre-assembly area. They'll be put into storage with the rest of the auxiliary structures. Even before the work is complete, the crew begin to dismantle the temporary foundations. They won't be needed anymore. On October 21st, 2016, the conveyor bridge returns to its operating position. After 3 months of downtime, the F-60 returns to operation. The spreader is another massive machine used in mining. The spreader follows in the wake of the F-60 and covers the last few meters of land with the topsoil that was excavated a few kilometers away just a few hours earlier. The last top layer has to be fertile topsoil. The land reclamation process follows strict guidelines. The new landscape of the reclaimed pit is mapped out before the excavation begins. Eventually, this reclaimed land will be covered with forests, meadows, and farmland. The mining industry has to follow strict guidelines for reclaiming the land that was excavated. This may look like a moonscape now, but in a few years, it will look like the surrounding countryside. The spreader crew has to know exactly what kind of soil is arriving on the conveyor belt and when. The different types of soil can then be deposited at the intended spot, so that the open cast mine can be restored to a flourishing landscape. The land reclamation plan is mapped out years in advance. It's part of the lignite mining approval process. The new landscape will serve a variety of purposes. Alongside forest and farmland, there will also be recreational space and protected areas for flora and fauna.
This is a very early stage in the reclamation process. There's not all that much growing here yet. This was probably excavated no more than 3 or 4 years ago.
Lausitz has long been known for its lush forests. That's why the first order of business is to replant the trees. Lignite or brown coal mining destroys woodland. When the mine is gone, the woodland needs to be restored. It all has to follow the strict reclamation guidelines. Because large amounts of lignite were removed, the new landscape will often be dotted with lakes.
We assess the area before the mining begins. If we find a special species of insect or reptile, or a plant that needs a great deal of water, we remove them and bring them here so that they have a chance at survival.
About 15 years ago, the F-60 removed lignite from this area. It's being restored. The new trees are now almost 8 meters tall. Before the recultivation process began, the new soil composition was examined. But the new trees and plants here will be monitored for years to come. Any tree or plant that isn't thriving will get some extra care and attention.
Take a look at this branch and these needles. They're nice and long. They have a good color, a nice rich green you like to see in a pine tree. So this is fine. But look over here, on the same tree. If you look closely, you'll notice the pine needles are shorter. And up here, they have a few yellow spots. This tree could use a bit more nitrogen. This is where we could help things along.
The F-60 conveyor bridge is the biggest self-propelled machine in the world. A giant made of iron and steel that can shift 90,000 tons of soil per shift. The Colossus moves its way forward through the Lausitzer landscape, scooping up soil on one side and disgorging it on the other. But the F-60 and machines like it aren't excavators. They lay the groundwork by uncovering the seams of lignite, the brown coal, so that the excavators can go to work. Refurbishing a monster machine like this takes years of planning and preparation. If the F-60 goes offline, it could pose a threat to the power supply of an entire region. This Colossus is the pride and joy of the mining crew, the biggest conveyor bridge ever built, and the biggest self-propelling machine in the world. F-60 Conveyor Bridge.